Everyone. While people keep pouring in or something, I have a few announcements to make. The talk here will be Peter Gleisner with talking about various bootkits, especially his new bootkit Stoned. Um, but while we wait for you to settle, some announcements. Um, I've asked around at the speaker's desk and info desk if they have anything to say, and there's quite a bit. For one, what kind of geeks are you? We use only a tenth of our bandwidth. Use more bandwidth, says Infodesk. Also, okay, but please use like wires, cables when you use more bandwidth. There's also a Twitter stream from the Infodesk. It's on the wiki page where they announce lost and found stuff. Many things, many curious things have been found, and if you miss something, just go to the Infodesk. It will probably be there. Also, HAR is very much based on volunteering, so most of the guys here is volunteers, I think all of them. And you can help too by going to volunteer.har2009.org and signing up for various tasks like shifts on the Infodesk, standing behind the bar, helping out with various stuff. Please help out, it will be much appreciated. Anyone still coming? Of course they are. But I think we're already up here, so this is Peter Gleisner, sorry again, sure. With Bootkits and Stoned.
Okay, thank you. Well, very good evening, ladies and gentlemen. I want to talk about the rise of MBR rootkits and bootkits in the wild, and I will also show you my Stoned bootkit, and I will talk about a few things I've experienced and also recently, and there are some really, really interesting things and topics about bootkits and how you can use them. And I want not only not to cover the bootkit itself, but also the technique how to use it and how you can take advantage of it and how you can install it and basically how you can use it productionally. And of course I will also go into the history because previously there were some very interesting bootkits and more bootkits than you think there are, which have all the value in the timeline. And I will also talk about the future, what's upcoming then. And I am Peter Gleisner, and since I've worked for 1 year at the antivirus company until last week, which is a really interesting story because I have spoken at Black Hat also about the Stoned bootkit, and there were some misleading information and the media did not respond the same way I have spoken, and so people stated me as hacker and sent the company I've worked some emails and complained about it. So I lost my job, and right now I'm going to do my own startup, Insecurity Systems, which should handle security and insecurity of operating systems, making the products more secure and penetration testing them, also encryption software and all those stuff. A bootkit is a rootkit that's resisting in the master boot record, which is directly loaded by the BIOS. So it's the very first software that's executed on a computer. And here also the problem starts because the master boot record is not secured, and thus you do not have a trusted chain. And this means that the whole computer is insecure because the master boot record is insecure. And you can simply replace it with your own code with a rootkit or a virus, which could capture your keys or just being memory resistant. And the interesting thing of the bootkit is that it has to load a part of the operating system. It's not a typical rootkit that's installed in the operating system. but it's active before the operating system. And for acting beside the operating system, it must specifically handle it and must be capable of going all the way through the transition from protected mode up to the running kernel, and must be able to be executed beside the kernel. In the history, we have seen different rootkits which have done different things, and for example, we have dedicated rootkits like the bootroot, which attacks only Windows XP, and others like Bootkit, which attacks only Windows 7. And my Stone Bootkit attacks now all Windows operating system from 2000 up to 7 with 1 mass boot record. So it's much more stable and much more a production release. And bootkits have a long history. They started in 1987 with the original Stone virus, which was just a worm. It just infected all floppies and hard disks that were available on the computer. And it was quite common in the mid-90s. And it's very interesting, and a very interesting bootkit because it was not operating system dependent. It just copied itself, and it monitored the disk I/O system, and on every read and every write on any disk, it checked if it's already infected, and if not infected it, and thus it was quite famous and quite much widespread. And today bootkits also have they have a target. For example, the bootroot and Bootkit, they were just proof of concept. And we have seen now also a malicious bootkit, MapRoot, which steals banking data. And also a very different one, and one which was not discussed previously, the Vista Loader, which I'll discuss later. And there is also a long list of bootkits presented at security conferences. But still, there is not a lot of information about bootkits and about the pre-boot environment and how to develop them and how to develop with them. And this is also why I'm going to hold this presentation. The typical usage of rootkits is, for example, for the original Stone bootkit, it was just printing out a message, your PC is now stoned, and just infecting. So basically just a worm. And now near bootkits like the MapRoot is stealing banking data. And for example, Comboot, which is also quite famous, bypasses the Windows and Linux security and the logon, so you don't have to enter password. And you can then take the CD with Comboot and go to a computer and start it, and you don't have to know the password of it, and you can still access then the operating system. And my Stone bootkit should be used for forensics and could also be interesting for law enforcement agencies because it's also bypassing full volume encryption. And so you can go to a computer which is fully encrypted and put with Stone your software on it and install it. And when the user goes to the computer and start it up, it will become active when they enter the key, the password, and then it becomes active and has access to all the data. It's running beside Windows and can then basically do everything a normal Trojan can. And I also want to handle the Windows product activation. This is also a part of the Vista Loader. And for the previous Windows operating system, with Windows XP, there was an OEM key. And with this OEM key, you could activate the computer without an internet activation. And this was done and required for big companies. And with Windows Vista and Windows 7, they have changed that. There are not just keys that you enter and then you just have it activated and no internet connection required. But they have modified it that you have a special table which is created by the BIOS in your system, which identifies the computer as OEM. And if you have the table and the certificate and the key, then you don't need an internet activation. And this is very interesting because Microsoft has a secret agreement with computer manufacturers and to include the table, and if the table is included, then it says, okay, it's OEM, it accepts the certificate and the key, and there's no internet activation required. And the special thing is that it's all done by software, and so you can also spoof it. And actually, it's also spoofed already. And it all goes to a small table, the software licensing internal code, which are just 374 bytes, which contains an RSA key, and which is just based on ACPI tables. And here you see the structure of it. The RSDP, the root system descriptor pointer, points to another table, and that table points to some other tables which are responsible for handling different things like the processor configuration, the multiplicator, making faster, slower, and providing some capabilities like shutting down the system and hibernation. And these are just used to identify the computer. And it was invented in 2000. And the BIOS sets these tables up, and Windows and all operating systems can use them and interpret them, which is a much more secure way than it was previously done. And this special table is not different than the others, which describe just the system and what features it has and how the system just acts. And so this table just identifies it as OEM. And here you also see you can simply trace it down, and you can go to a system that has this table and just copy it out. And when you have it, you can extract it, and you can also write a bootkit and let the bootkit writing the table, and then your computer would be spoofed as OEM. And beside the ASLIC table, you also need to have the certificate and the key. And here you see the contents of the ASLIC table, just 374 bytes. And it's built up with a description header, a short header, the first 4 lines, which identify the table, which is just a normal ACPI table. And then you have the RSA key and some other stuff that is used. And here is also the OEM identifier, which is important because you need the same OEM identifier for the certificate and for the table and for the key. And if they are all matching, then the system will be noticed as from the manufacturer and will be activated. And you can also use these 3 things from another computer, like from an Acer, and put it on a Dell, and it still works. And the certificate is not that big. It's a simple text file, and you just have to install it using available script. And this is also done automatically for huge installations of Windows. The OEM key is also required. This is the last step. And if Windows notices the table and the install certificate, then it will accept the OEM key and will activate it without any other requirements. And this is the system lock pre-installation master product key. So you use this just for all notebooks. And there was previously last week also in the news that for Windows 7 there was also the master product key leaked, so which could be used for activating then all computers in the world using the ASLIC table and using the certificate. So what Microsoft did was just changing the key for the manufacturer and then just blacklisting it, which is not a good solution because, of course, next week when it comes out, then they just can grab the key and everything and just redo the thing. And as I've mentioned, Bootkit can also set up this stuff. And this is also done by the Vista loader. There are different builds available, and most contain a Trojan or virus. And this automatically installs a short bootkit based on grub that inserts the table and registers the certificate and also registers the product key. So it's a full automated way to make your Windows genuine. And of course you can also do that manually on some Chinese hacker sites where the steps published that you have to unprotect your BIOS, and then you take the BIOS and in a hex editor you just replace another ACPI table. In that case the table was replaced, which is responsible for handling an older ACPI systems. So it's not any loss for new operating systems, new systems. And they make that just hardwired. So including this table instantly and not just moving it every time on boot. And of course Microsoft knows about it and does also things about it. They are also blogging about it in the VGA blog. And what they are actually doing is not changing the method, but they are just trying to find these tools and make signatures of it and just blacklisting it, and they are pushing out new Windows updates to detect them, and if they detect it, then they will invalidate your Windows copy, and then you will get such screens, and then they will say you have an activation exploit and illegal, and they want to protect you because the software is often harmful and contains stolen software. And they also say that you might be a victim of counterfeiting. And so it's not changing the method of it, but just recognizing the tools. And so it's simple for Rootkit because it must just stay under the radar. It must not be able to detect it, and then it can just spoof every time the table. And the point is that the Rootkit started before Windows, so before Windows started, the table is added and Windows will detect it. And for the installation, there are, of course, two different methods available. Either you need physical access or administrator rights on the Windows operating system. For physical access, you can just take a live CD or a live USB stick or floppy and infect the drive. Or under Windows, you have to get administrator rights, and under Windows Vista, elevated administrator rights. Otherwise, it will refuse to overwrite the masterboot record. And to get these rights, you can either put a manifest into your executable, or you do that on runtime using shell execute. And here you have a social engineering vulnerability, because you can call shell execute always in a loop, and then always the pop-up comes, the content user interface, which always asks, do you really want to execute the software? And when you say no, then you are just again calling it, and then the whole time the dialog comes and everything out is grayed out and you can't do anything. So this would be a quite effective way to gain administrator rights. And here you see it, you have to put the manifest file into the executable, and then when you start it, Windows automatically asks for it, for the rights. You can set different requested executed level rights, for example, as invoker or highest available. And when you set them, then Windows will ask for the rights. And for shell execute, there is an undercommitted option available. If you set LP operation to run as, then it always will ask for the rights. The environment Rootkit's running is the real mode. So when someone wants to write a Rootkit, it has much take care of the processor and the process environment more than about 16-bit code, which makes problems because everything has to be written in assembly language, and there are no or not much C compilers available that can compile it to 16-bit. And it must also be very low level and directly access the hardware and talks to the hardware. And it uses the BIOS, which is quite undercommented and unspecified, so there are really many problems, which is also why we have EFI in the future, but which has not changed yet, because no one of the vendor wants to change it. And I've also talked to Microsoft at Black Hat, and they told me also that the BIOS vendors don't want to change anything, because if it goes bad and they make something wrong, then they have to then have broken systems everywhere, and they would have to patch all systems with a new BIOS, so they just stay the same and remain the same like 20 years ago. And when writing a Rootkit, it must be memory persistent, and it must always copy itself to the next stage, and being able to transmit and come to the next stage. And when it wants to do some actions, it has to be specific the operating system files of it, and have signatures of it, so it stays undetected and both gets executed. And I've also mentioned that my bootkit is able to bypass TrueCrypt and full volume encryption, and this means just that you can install the bootkit on a fully encrypted hard disk, and it gets executed and is able to bypass the encryption using a double forward. And this goes also to the interrupt 13H, to the disk system, because TrueCrypt sets itself in there and decrypts and encrypts the whole contents, and the bootkit must be a layer below, so it gets the decrypted contents. And this is a generic way. I don't touch TrueCrypt in memory. I don't modify or patch it. And so this also works for other encryption software. I've tested it also with Descriptor, and it works fine with it. And for full volume encryption, you have two scenarios. One is that you just encrypt the system partition, then everything other stays unencrypted. So the master boot record is unencrypted, the other partitions and unused space is unencrypted. And the second scenario is that the entire hard disk is encrypted. And for this, but also the master boot record stays unencrypted. It always stays unencrypted, and it must stay unencrypted because it's the initial software loaded by the BIOS, and the BIOS doesn't know anything about encryption. So there is, and this is the big point, it's not encrypted, it's not any verified or checked, and so it can be simply replaced by my own software. And there is also another attack to TrueCrypt. It does not encrypt or hide the partition table. So if the whole hard disk is encrypted, I have the partition table and I know where the partition are laying and where is unused space, and then I can store my other files, my payload, my drivers, and some other boot stuff, because the master boot record is limited to 63 sectors. And this is not enough for a full software. And for owning the operating system, there is a generic way, and this can be used for multiple operating systems, not just for Windows, also for Linux. And it always starts with the master boot record executed by the BIOS. And then the first action to do is to hook the interrupt 13H, which is done to get the contents read by the operating system. So when the operating system reads the initial boot files, you can just check them against some signatures and patch them, modify them, extract information, or do whatever you want. And the Stone bootkit initially patches some code integrity verifications of the NT loader and the boot manager under Vista, and it patches it to get executed. And the next thing is to intercept the boot file loading routine function of the operating system to get called and get access to the whole boot files, which includes on the Windows the NTOS kernel or some boot drivers, and then you can simply also patch them, overwrite them, and this also handles then the sign checks, because you do that afterwards and you patch them, and Windows won't detect any modification. And the next thing to do is to hook the system initialization. So before the system will be initialized and all functions are called in the list, you can modify any image and can hook it, and then you can make a step, then everything will be initialized, and then you can use the operating system and other functions, and then you can connect to the internet or do something other. And for providing a generic way and also providing support for multiple operating systems, I have split it up into multiple parts. As you see there, for example, into bootkit real mode and protected mode, so the processor modes, and later then the operating system states, like kernel code is executed and driver code. And it also has its own PE loader, which means that the bootkit does not use Windows functions. So it resolves and does everything by own, so Windows won't get notified, and so antivirus products can't detect it. And there is always an advantage of bootkits against antiviruses, because they are loaded before antiviruses, so they can always hide itself. And the Windows boot process, as shown there, starts with the partition bootloader, which is specific to the file system, to FAT or NTFS, which loads then NT loader or the boot manager, depending on XP or Vista. And then it goes through the OS loader and WinLoad X into the NT kernel. And the NT loader is a 16-bit stub. And it's very interesting that this 16-bit stub is not verified. So the bootkit could also be placed into the NT loader and not just into the bootloader or the master boot record. And there is the OS loader appended to the NT loader, which is just binary appended. So it contains a 16-bit stub and a full qualified 32-bit PE file. And Windows Vista has split it up, the NT loader, into WinLoad exe, into WinResume exe, and into the boot manager, and additionally the memtest. And here is also the processor environments, which are very important for the stages, and the bootkit must always ensure that it's going to be the next stage, because when it's in real mode, it must ensure that it gets executed in protected mode. And of course, there are not just on-the-fly attacks, not only in the memory attacks. You can also write a bootkit that just does something like the Vista loader that modifies the system before everything has started. And I have previously written the hibernation file attack, and the bootkit is also based on that. And the hibernation file attack was just to inject code into the hibernation file and parsing its structures and looking for some code and replacing it. And the hibernation file was not verified. There are no checks done. You can set checksums to 0, and then there are no checksums calculated and verified. So the operating system was owned before it started. And the whole magic behind bootkits are the signatures, which are very important, and which also makes it possible that the bootkit is able to support multiple operating systems. And it has these signatures to get executed and it stays undetected. And these signatures are similar for different systems, but have very often some slightly different. For example, 1 byte just different. So it's quite simple making it working on multiple systems. And here you see the signature for bypassing the code integrity verification of NT loader, which are just some bytes. But these bytes are assembly code instructions, so they are always working for multiple operating systems, because even if you recompile it or if you modify it, the code will reappear and will work again. And of course, there are some solutions to close out bootkits, and the best one is the trusted platform module, which takes hashes of every boot file, including the BIOS and the master boot record at the bootloader and all boot files of Windows. And if you use that in connection with full volume encryption, then the trusted platform module will give only free the hash, will give only free the key if all hashes are valid and are the same as internally stored. So this means that you can only decrypt the drive if nothing was modified. And full volume encryption software could also secure its software. It could simply disable MBR override in Windows, which would make perfectly sense, because why should someone override the software? That would just make damage. And it could make some verifications if the MBR was modified and could restore it. And of course, you can make another dedicated attack against it and patch the verification, but it would close out all previous bootkits and would make it much more secure. And also the attacking vector should be considered, and not just that it's just encryption software, but also the security of it. And it should not just state that it requires physical security, because this is not always given. And bootkits might become also interesting for law enforcement agencies, because you can simply use it to install a Trojan on a fully encrypted computer, and the bootkit stays undetected and can't be detected if it's code written, and it has full access to the entire systems. And the only disadvantage is that this requires physical access, but which would be good for operative usage. so that someone, if you have a suspect that you are going to his computer, starting via live CD and installing the Trojan, and then the Trojan is mailing you just everything data you want. And my Stone Bootkit works for all systems and also for a full volume encryption system. And I've also included some features like boot applications and plugins, so it's easy to develop it further and integrate some other bootkit stuff. And the target is to own all Windows operating systems and to be able to patch the system and to bypass the code integrity verification to sign driver checks and to create a quite sophisticated bootkit. And like the original Stoned virus, my Stoned bootkit is displaying at the startup your PC is now stoned again, and in a probability of 1 out of 8. The architecture is quite modified than other bootkits and is quite new because I'm not only using the master boot record but also system files stored in the file system or to unpartition space, and I'm including my own FAT and NTFS file system drivers, so I don't need Windows to load my files, and this means I can just include much more code and for example payload drivers and everything and the Trojan or some other software, because I'm not only fixed to the 63 sectors. And I have decided to make it modularized, so it just consists of multiple modules and everything is independent from each other. And you can take a module and use it without the others, and makes it much easier to develop with because you just have to recompile one module and not have to test and everything other. And as proof of concept, I've included in my Stone bootkit CMD extra privilege escalation, which is a normal driver written using the Windows driver kit, which just escalates the rights, the security rights of the CMD extra process to system from the normal user. And it should never happen that a normal user application gets system rights. And for this, I'm showing you now a demonstration with a new live CD. And this is based on Windows PE, and it infects now any drive, and will store the bootkit on the hard disk, which is fully encrypted with TrueCrypt, and then the bootkit becomes active, and you can see then that getting full access rights and can do everything at once. So what I'm going to do now is restarting my system. And using a live CD containing my infector. And this would be then really a practical usage because someone would just need this live CD or could also store it to a USB stick and simply execute it, and even if the hard disk is encrypted, he can store his own software. So I'm starting now from the CD, which is based on Windows PE. I've created it with the Windows Automated Installation Kit, a framework which you can use to create your own Windows PE image. And the Windows PE is just a more dynamic version of Windows containing just the necessary files to load Windows. And it loads just a few files and is more fast and has only the basic features implemented, and it does not contain any graphic user interface, not a shell or something, only it just executes my application. And this is the latest one. This is based on Windows 7. And here you see the software. It won't display in the Explorer, and I have just to click this button. and it tries to write first the whole boot files on any drive that it finds, and then it tries to infect the physical drives. And here in this line, you see that the master boot record was successfully replaced. So my bootkit was installed, and I can now restart the computer. And there's the 1 in 8 probability that it shows up, your PC is now stoned. Okay, we won't get it to see. Now I still have to enter my password. Secure is secure. I think you wouldn't remember the password even if I tell you, so. And my bootkit becomes now active beside the Windows operating system, beside the kernel, and patches also some system files. Only in the memory, it does not modify anything on the hard disk, which makes it also much more difficult to detect because antiviruses products just scan the disk. And of course, you can also scan the master boot record, but it's very easy to spoof it. You just need a driver that it's below the normal Windows driver, and then you can intercept it and just return another master boot record than which is really stored. Which is also done, for example, MapRoot does a very good job with hiding itself. So once it's installed, it will be never detected and makes it really hard to find it. So I'm opening now my CMD exe console, and I'm also showing you a debug view, which displays debug messages that's sent to the kernel. So you can also see what the bootkit is doing inside, which is a very, very useful tool for testing. So it should capture everything. And if I enter now, who am I? Right. Okay, it's not cool. It seems that it doesn't seem like it's running. Okay, it's bad. There must be some mistake. Okay, well, but I will publish the CD so you can test on yourself. Yeah, but that's not from the bootkit. That's some Windows stuff. Normally it would display images that are loaded, and the privilege escalation would display, when I type in who am I, it would just go through all processes and find the services exe process and copies the security token to the one of the CMD exe. But it doesn't seem like it's working. I finished it today at 2 a.m., so it's, yeah, not that good. But, well, to continue, like I said, I've also included boot applications and plugins. And one example plugin is the CO2 plugin, which throttles down the CPU to 80%, also using the ACPI and modifying a table of it. So it reduces the CO2 output. And it's also quite interesting because it uses open source. The source code was originally used for DOS to slow it down to work for the old DOS games, and I can now reuse it. And another example application of it would be using it as extractor for other malicious software, because the bootkit does not use any debug breakpoints or any stuff that reverse engineering tools are using, so it's undetected. And I've written a Cineval extractor which extracts the unpacked kernel driver, because Cineval, a banking Trojan, is highly encrypted, and it just lets execute Cineval, and it will detect when it's decrypted and unpacked, and it uses for that not breakpoints but export hooks. So the hooks are installed into by Windows into the program using overwriting the export table of the NT kernel, and it writes it out to disk for further analysis. And here we can see, for example, the result of it of the code that is used for the command and the name generation, and also you also see the commands you can send to the Cineval software. And for the future, I want to make it totally operating system independent. I want to cover Linux and also 64-bit operating systems, because it currently just works for 32-bit. And for my next presentation, I also want to defeat the trusted platform module, because it has some security flaws, or better saying, the implementations are not the best. So it's also possible to bypass them. And for my whole topic and talk, I've used some references. There are great papers available of other researchers, which also helped me and get me into the topic. And they're really great, you should see them. And I want to thank you all for your attention, and I really appreciate that you're here, because it's really night and it's nearly 23 o'clock, so thanks for your attention.
Are there any questions? Really?
Hey dude, how's it going? I saw you in
Fine.
Vegas.
Fine, yeah.
It worked in Vegas. He's not kidding. So I was thinking, what about T-list? What about task manager? What about process list? If I do those various things, am I going to see anything that's going to indicate to me that I've got an infection in memory?
No, you won't see anything, because it's not a registered process or task. So the the task manager won't show anything up, and it's executed beside the kernel, and you won't detect any change of it. It stays undetected.
Hello, one question. You need access to the master boot record. If you have a full disk encryption, half a full disk encryption on the hard disk, is that protecting you against that? Because you must first access the MBR to do the infection, right?
What? Sorry?
If you have a full disk encryption, half a full disk encryption on the disk, for example, Seagate or Toshiba are now bringing out hard disks which have on the disk Rindal encryption. Is that protecting you in any way?
If the master boot record is protected?
Yes.
No, it's totally unprotected and unsecured, and this is really the weak point on the whole thing. And this is why I just can't do the whole attack, because the master boot record is just not verified, and you can simply replace it.
He was talking about hardware.
Hardware encryption. Yeah, well, for hardware encryption, you have to consider the two ways for physical access. This would basically protect it. But if you execute the infect on the Windows, then the hardware encryption is a layer below, so you could still infect the drive under a running system. So hardware encryption just secures it for a turned-off system. Any other questions? Yeah, BitLocker uses the trusted platform module. So it's not working with it. At least it will just make your system unusable, because when you start, it will tell you that the hashes are no longer valid, and you can use then the recovery CD, or your system is fucked. And this is a bit of disadvantage, because if anything is not the same and if the hash is no longer valid, then you cannot decrypt the drive. This is then the bad thing about it.
How would you go about to detect if your PC is stoned?
How what?
How would you detect if the bootkit is installed on your PC? How would you go about it?
I would simply check the master boot record in hex editor because currently I'm not spoofing it. I'm not trying to hide the master boot record. But otherwise there are not good chances. Sorry, what? Yeah, you can. Yeah, that's right. You can boot from external media, from a live CD, and then verify the boot record. And there's also antivirus software available that can do that. So this would also work out. Thanks.
Well, thanks everyone. Have a good night, and please, again, consider volunteering at volunteer.hard